So, hello students. Today we are going to start chapter number 5 of class 8, that is special types of quadrilaterals. Okay, so in this part we are going to learn about the different types of quadrilaterals. Already we have seen that what is a quadrilateral. Okay, so what is a quadrilateral? A quadrilateral is a closed polygon. We can consider that here ABCD is a quadrilateral. Okay, so it is a closed polygon made up of four sides. So one, two, three, four. These are four sides, and it has four angles. That is angle A, angle B, angle C, and angle D. Okay. Now let us learn what are the special types of polygon. Sorry, quadrilaterals. Okay. So we are going to learn about trapezium. Now, when a quadrilateral will become a trapezium. Okay. So here we can see that this ABCD is a quadrilateral. Now, in this quadrilateral, it can be seen that one side, that is AD, is parallel to BC. Okay, so if in a quadrilateral only one pair of opposite sides are parallel to each other, then such a quadrilateral is known as trapezium. Okay, listen once again. What is the condition? That if in a quadrilateral one pair of opposite sides are parallel to each other, then such a quadrilateral is known as a trapezium. Now here in this figure it can be seen that AD is parallel to BC, that is this AD is parallel to BC, which is given by this symbol. Okay, so what can we say further? Therefore quadrilateral ABCD is a trapezium. Okay, now one more thing can be seen in this trapezium. Okay, now as we have that AD is parallel to BC, we have learned about parallel lines, that when two lines, suppose these two lines are parallel to each other, this is line L, this is line M, and if a third line N intersect both of them, then this N line is known as a transversal. Okay, so let us apply that properties over here. So here it can be seen that AD is parallel to BC. Okay, so we can have some conditions over here. Now what is the condition? That when AD is parallel to BC and AB is the transversal, means this line is intersecting AD also and BC also at point A and B. So this line will be our transversal. Then during such a condition we can say that now this angle A plus angle B, these both are co-interior angles, and their total will be always equal to 180 degree. Okay, we have written here reason also, that is co-interior angles. Similarly, now when AD is parallel to BC and our next line, it can be seen that this DC is also intersecting these two lines. Okay, so we can say that DC is what? Our transversal. If DC is a transversal, then here also these two angles become co-interior angles, and if they are co-interior angles, then their total is also equals to how much? 180 degree. That is, we can say that angle C plus angle D equals to how much? 180 degree. Okay, now let us see our next type of trapezium. Okay, now in this trapezium, the one which we have seen first, only we consider that AD is parallel to BC, and these both are AB and CD, these are non-parallel sides. Sorry. Now these non-parallel sides, it can be seen from this one that they are unequal, and this indicate the sign for parallel. Okay, so now here in this next trapezium, which is known as isosceles trapezium. Now when a trapezium can be an isosceles trapezium, okay, or when a quadrilateral can be an isosceles trapezium, for that now this PQRS is a quadrilateral. Okay, but it can be seen that from this we can understand that these two sides are parallel to each other and both the sides are opposite to each other. So we can say that one pair of opposite sides are parallel to each other. So it is a trapezium. Okay. Now let us look at about the non-parallel sides. So this PQ and SR, these both are non-parallel sides, and these both are also equal. So such a trapezium in which the non-parallel sides are equal to each other, such a trapezium is known as isosceles trapezium. Okay, so here in this figure, what can we say? Now, in this figure, PS is parallel to QR and side PQ is equal to side SR. Therefore, we can say that quadrilateral PQRS is an isosceles trapezium. Okay, hope this concept must be clear to you when a given quadrilateral will be a trapezium and when it will be an isosceles trapezium. Okay, now in this isosceles trapezium also we can say that as it is a trapezium, that is one pair of opposite sides are parallel. So when PS is parallel to QR, this PQ will become the transversal. Okay, now when PQ will be the transversal, we can say that angle P plus angle Q equals to 180-degree reason co-interior angle. Similarly, when PS is parallel to QR, SR is the transversal, that is intersecting it both. So we can say that angle S plus angle R equals to 180-degree. Okay. Now let us solve some examples based on this concept. Now here we have our first example as in figure ABCD is a trapezium. Okay. So let us see the figure also. So ABCD is a trapezium. From figure it can be seen that these two sides are parallel to each other. So it is a trapezium in which AB is parallel to DC. So AB is parallel to DC. Okay. Angle A is 105-degree. Angle B is 115-degree. We have to find the value of this X and Y. Now, as it is a trapezium, it can be seen that one pair of opposite sides are parallel. So what we have to do? First, we will consider that when AB is parallel to CD and AD is the transversal. Okay, let us see what happens. So now, when AB is parallel to CD and AD is the transversal, so what can we say that angle A plus angle D will be equals to how much? It will be equals to 180-degree and reason will be co-interior angles. Okay. Now, what is the value of angle A? So angle A is 105. So instead of this A, what we will write? 105, and instead of this D, we will write there X. Okay. So in next step, what we get? 105 plus X equals to 180. Now what we have to do? We will keep this X on one side, remaining all the numbers on the other side. Okay. So if this 105 comes on this side, it will be subtracted. Okay. So in next step, you will get X equals to 180 minus 105. Therefore, X equals to 75 degrees. So this is our answer. Now, similarly, now we have to find the value of Y. Okay. So we have the same figure copied over here. I'm just making it B. So now we have to find the value of this Y also. So same condition, AB is parallel to DC, and this time who will be the transversal? BC will be the transversal. Okay. So now when BC will be the transversal, we can say that angle B plus angle C will be equals to 180-degree, and reason will be co-interior angles. Okay. So now what is the value of angle B? So that is 115, and C, so that its value is Y over here. Now in next step, what we will do? We'll change the side of this 115. So if it goes on the other side, it will subtract. So in next step, you will get Y equals to 180 minus 115. Next step, you will get Y equals to 65. Okay. So this is our final answer. So in this way, by using the property that these two lines are parallel to each other and third line is a transversal, then the co-interior angle, their total is equal to 180. We can solve examples based on trapezium. Okay, so this much is enough for today. Thank you. Have a nice day.